Hello everyone, welcome to another lecture of industrial engineering. In the previous lectures we studied about economic order quantity, and in this lecture I intend to do some problems related to economic order quantity. So let's see the equations which we will be using. Like as we already discussed in the previous lecture, the economic order quantity has a final equation like this. So those who did not get an idea about this equation, the derivation is given in the previous lecture. Please refer to that. Now we'll start today's lecture by doing a problem. So the rate of use of a particular raw material stores is 20 units per year. The cost of that is 20 units per year. The cost of receiving and placing an order is rupees 40. So what is that? That is the procurement cost P. The cost of each unit is 100. The cost of carrying inventory in person per year is 16, and it depends on the average stock. Determine the EOQ. Like from the previous slide, we know EOQ is equal to Q is equal to root 2AP divided by C. What is A? A is the total items consumed per year, P is the procurement cost, and C is the annual inventory carrying cost per annum. Okay, now let's start doing it. Again we write Q. So we will have to find out the value of Q in this particular problem. So Q is equal to 2 into AP divided by C. So what is A? A is the number of items consumed per year. So what is the number of items consumed per year here? So that is 20. In this particular case it is 20. And P is the procurement cost. Procurement cost here is the cost of receiving and placing an order. So that is something around 40 rupees. Now the cost of each unit is rupees 100. The cost of carrying inventory in person per year is 16. So in that case we know that C is the annual inventory carrying cost per item per annum. Okay, so that is also equal to total, like in the previous slide we know that is the total annual inventory carrying cost divided by total items consumed per year. So we know the total items consumed per year, that is 20. So in this case C is equal to total annual inventory carrying cost divided by the total items consumed per year. Consumed per year. Now total annual inventory carrying cost is equal to the total items consumed per year. So what is the total items consumed per year? So that is 20 into the cost of each unit, that is 100, into the percentage of carrying cost, that is in this case it is 16%. So I'll write it as 0.16 divided by the total items consumed per year. So it will come to something around 16. So this is the carrying cost. Now you have the value of A, you have the value of P, and you also have the value of C. So total annual inventory carrying cost is actually the product of total items consumed per year, okay, into the cost per item that is 100, and the percentage of inventory carrying cost. So it will come to something around 60. Now you can find out the value of Q, the economic order quantity, from this particular equation. So that is 2 into 20 into 40 divided by 20. So that will be 10. So it is economical for the company to order 10 items, so that the cost will be minimum. The inventory cost will be minimum if you order 10 items. Now, once more, let me be clear that the total annual inventory cost is actually the product of total number of items, cost of each unit, and the percentage of carrying cost. The cost of carrying inventory in percentage per year is 16% here. So it is actually the product of these three values, and if you divide it by the total items consumed per year, that is, in this case it is 20, you will get the value of the carrying cost per annum. So that is how you do this. Hope it is clear. Okay, now to understand the concept better, let's do one more problem. In this particular problem, a manufacturer has to supply his customers 3,600 units of his products per year. So that is the demand. So what is that? That is A. Inventory carrying cost amounts to rupees 1.2 per annum. So you need to be very clear about this term, that is, this is given per annum, so you can directly take the value of C. So that is rupees 1.2. So 1.2 per unit per annum. So the value of C is actually per annum. So that has to be clear. In the previous problem, it wasn't per annum, so you had to calculate the value. Ordering cost per run is rupees 80. So the procurement cost is rupees 80. Now find the value of EOQ, the optimum number of orders per annum, minimum annual average inventory cost, optimum period of supply per optimum order. So you are supposed to find out all these values. Now let's write what all are given here. The manufacturer has to supply his customers 3,600. So what is that? That is A is equal to 3,600. Now the inventory carrying cost, so C is equal to 1.2. So C is equal to 1.2. Ordering cost, that is the procurement cost, P is equal to rupees 80. So everything is given, so you can directly find out the value of EOQ. So Q is equal to root 2 A into P divided by C. So what is the value of A? It is 3,600. The value of P is 80, and the value of C is 1.2. So it will be something around 693 units. Okay, so the first part is over. So part A of the question is over. Now let's go to part B, the optimum number of orders per annum. So a typical order with minimum cost should have 693 units. So the annual requirement is how much? It is 3,600. So what is asked to find? What is asked in the question? The optimum number of orders per annum. So how many orders should be placed in order to meet this 3,600? So one order should have 693. So how many units? So how many orders should we make? So one order has 693 units. We can write it as optimum number of orders. optimum number of orders is equal to the total number of units required, that is 3600 divided by 693. So you can approximate it to something around 5. Okay, so there should be minimum 5 orders so that the cost will be minimum. So you got the optimum number of orders, and let's go to the next part, that is minimum annual average inventory cost. Minimum average inventory cost. So from the previous lecture we know that the total inventory cost is equal to Q by 2 into C plus A by Q into P. So that is 693 divided by 2 plus into, I'm sorry, into 1.2 plus 3600 divided by 693 into 80. So this is the total inventory cost, or the minimum annual average inventory cost. So that will be something around 831.38 rupees. So you got part C. Now optimum period of supply per optimum order. So number of orders per, so what does this mean? Optimum period of supply per optimum order. So when should the supply happen? So we found out the minimum number of orders to be 5. So there should be 5 orders per year. So when in an year should the order happen? So if there is 5 orders, so when in an year should this order happen? So number of orders per year is how much? 5, right? So optimum period of supply per optimum order is actually how much? 1 divided by 5. That is when the order should happen. So it should happen something around 0.2 years. So if there is 12 months, you divide it by 5 and you will understand in which month the order should happen. So that is the optimum period of supply per optimum order. Hope the idea is clear. So optimum period of supply per optimum order is happening at 0.2 years. Now we will discuss the next kind of inventory model, that is the inventory model with shortages are permitted. So in the previous case we didn't consider about a case where there would be shortage, but in this particular case we consider the inventory model to have some kind of shortage. So that is the total stock, it goes out of stock. So you can see from here, but in the previous case the order used to happen from here, right? So there was no question of the order going to 0. So there was instantaneous replenishment of your order. But in this case what happens, there is a certain bit more time for reordering your product. So it goes 0, the total quantity goes 0 and it goes back, it is idle here, right? So this was the time which was supposed to be the completion time. This was supposed to be the completion time, but it did not complete during that time. It again went back to this particular time. It took an extra bit of time tz Why? Because the stock went to 0. So if the shortage or stockouts are allowed in the inventory, the cost of shortages will also be there. So in order to satisfy this particular time, there will be an additional cost which is involved in this particular model. So that particular cost is called as back order cost. So it is represented by CB. So the economic order quantity Q can be found out by root 2 AP divided by C into C plus CB divided by CB, where CB is the back order cost, and the other terms is the same like we already saw in the previous case. Now to understand the concept better, let's again do a problem. So in this particular question, the demand for an item is uniform at a rate of 300 units per year. So the value of A is 300 units per year. Now ordering cost is rupees 360. So what is ordering cost? That is the procurement cost, that is 360. The inventory carrying cost is rupees 6 per unit per year. So it is directly given. The value of C is 6 per unit per year. So that is rupees 6. And if the shortage cost is rupees 3.6 per unit per year. So what is a shortage cost? That is CB. CB is equal to 3.6 rupees. Determine the value of EOQ. So this is direct substitution. So EOQ Q is equal to, or it was mentioned as Q star, is equal to 2AP divided by C into C plus CB divided by CB. So it is directly direct substitution. You can find out the value from this equation. So the value of A was 300, the value of P is 360, 6 plus 3.6 divided by 3.6. So you can find out the value, and the value comes to be something around 2166 units. So this is how you find out the economic order quantity where the shortages are permitted. So you will have to add another term that is called as the back order cost CB. So that is the only difference in this particular case. Hope the idea is clear. If you have any doubt, please let me know. Thank you.